And welcome to the very first section of our LPIC 1 training. Now, the first chapter, or the first section, is 101.1, and it's talking about hardware settings. Now, this section has a weight of 2, which means on the test, you can probably expect to have, honestly, just about 2 questions that have to do with the subject matter we're going to talk about. However, we don't know exactly what topics it's going to be on, and as you can see here, there's all kinds of stuff to learn. So we'll just teach everything, and then you'll get asked 2 questions. It'll be easy, and you'll just be terribly proud of yourself. So anyway, basically we have 2 sections. We're going to talk about how we determine settings on hardware, and then how we configure settings for hardware. We're going to talk about HAL, which is not the robot from Space Odyssey, although that's cool. We're going to talk about dbus and udev, the Sys Directory, the Proc Directory, the Dev Directory, LSMod, LSUSB, LSPCI. Have you fallen asleep on me yet? Because we're not quite done. Then we're going to learn how to configure those things. And that's going to be the section after we learn how to discover stuff. So let's dig right in and learn about, first of all, what some of these things mean, and then what we can learn by looking at them. Okay, now before I actually show you some of these things in action, we have to define some terms. Now, we're talking about HAL here, which again is not the robot from 2001 Space Odyssey. That would be HAL 9000. But no, HAL in Linux is the hardware abstraction layer. Now, what that means basically is, let's say you have a server with like 3 different network cards in it. Okay, one network card is an Intel card, another card is a 3Com card, and let's say the third card is, just something you found on the shelf, and you're not even sure what brand it is, but Linux is probably going to support it because Linux usually does. But you plug them all in. Now, in some other operating systems like FreeBSD, depending on the brand, they're going to have different device names, like how you refer to them in your configurations. What the hardware abstraction layer in Linux does is it says, okay, you plugged in an Ethernet card. I know it's an Ethernet card, so we're going to say that since it's the first one I've seen, the name of it is ETH0 or ETH0. Now, it doesn't matter if it's an Intel card, doesn't matter if it's a 3Com card, it's your network card, it's ETH0. So it's a really nice way that it really does that. It abstracts out the idea of what brand devices you're putting in, which is a great way to make replacing hardware easier. For example, if your network card dies, you plug in a new one, bam, it's going to be ETH0. Really, really, really nice. Next we have dbus. Now, I actually like to think of dbus as an actual bus. Here, I'll draw a bus because this is getting kind of dry. Okay, so it's an actual bus, wheels, windows, looks a little bit like a plane maybe without wings. Anyway, dbus is the way that the kernel, or HAL, the hardware abstraction layer, communicates with things like the desktop manager or other hardware. For example, if you plug in a USB drive, dbus can tell the operator, tell the GNOME desktop or whatever desktop you're using, hey, I found something here. I'm not going to tell you what brand, but it happens to be a USB drive. You want to do something with it? And then the GNOME operating system or your KDE desktop can do whatever it wants with that information. But dbus is the way that that information is traversed between applications and the hardware abstraction layer. So anyway, that's what dbus is. It's a communication methodology or communication pathway for the different things to talk. And again, I think of it as a bus. But if I had to give it a definition, I guess communication with hardware and software. So do with that what you will, or just remember the bus because it's easy to remember. Now, udev is the last thing on our list. Now, what makes udev neat is in traditional Unix or Linux file systems or device file systems like dev, which we're going to talk about in a little bit, you would have a whole list of devices. I mean, there would be just a huge list. Dev SDA, Dev SD, DB, Dev, boy, my handwriting's horrible, SDC, all the way down the list. And you would plug in something, and when you plugged it in, the first one would be on the node SDA, the second one would be SDB, and you just kind of had to guess and hope and try to do some weird testing to figure out where things were when they plugged in. Well, that's where udev comes in. Right now, when your system starts, it doesn't have those devices. It actually creates them on the fly. So instead of just this long list of devices that you just hope to guess, and this was really a problem with things like Palm Pilots because you just never knew exactly what device they were. But what UDEV does is it says, okay, it's communicated to by the hardware abstraction layer, and it says, okay, I've plugged in a block device. It says, great, it's a block device. Let me look at it a little bit, see what it is. Okay, it turns out it's a USB drive, so we're going to assign it to dev SDA because that's not used yet, so this is going to be the drive. But then you can write UDEV rules and take it even further. So it's going to look at what SDA is and look at the serial number or other specifics that it can get from the device and say, okay, I sniffed it, or I wrote this rule and I discovered that not only is it a USB drive, but it's like my new 16 gig Toshiba flash drive. And I always want that mounted under dev awesome, because I'm really proud of my flash drive apparently. So dev SDA is now symlinked to dev awesome, and UDEV had that happen. So basically what it said is, okay, I mounted it as dev SDA because it was plugged in, but then looking at the rules, the UDEV rules that were written, I saw that it's this particular device, and I want to call that dev awesome. Now, you don't normally get things like dev awesome. Really, what normally happens is you say, oh, it's a Canon camera. So let's also, instead of awesome, let's say, okay, I plugged in my Canon camera, right? So what are we going to do? Well, we're going to link that to dev camera. And then, using the dbus system, GNOME says, hey, I know dev camera. When dev camera pops up and appears, or it is transmitted on the dbus system that dev camera came online, I'm supposed to open up gphoto and suck all the camera pictures out of it, right? But it can't listen if it's just dev SDA, because that could be any USB device that was plugged in. It's only with the UDEV rules that then creates dev camera that dbus says, oh yeah, I know dev camera, that's what I want. So again, UDEV lets you do more fine-tuning of the devices as they're plugged in. And it's a huge improvement over just this long list of pre-existing nodes that populated in order that they were plugged in. It used to be a real mess. But with UDEV, things are a lot simpler. And next, we're going to look at what those different file systems look like when they're populated, like the dev directory and the Sys directory and the Proc directory, and see what all those things mean. But you have the gist here. You have the hardware abstraction layer. You know that means it's going to say, a USB drive is SDA or an Ethernet card is ETH0. dbus is the way they communicate that with like the desktop manager, GNOME or KDE. And then UDEV does some really cool, not quite magic, but some pretty nifty stuff where it will determine exactly what kind of hardware you have based on UDEV rules and create links like called camera when you plug in a camera. So anyway, that's it. We're going to move on to what's actually in those files. We get to look at a real computer. Woo-hoo! Okay, so next we're going to look at the Sys directory, which is the Sys file system, or sysfs. Now this, I know I said we're going to look at a computer, and we are, bear with me, but this is where HAL keeps its database of devices that are connected to the computer. Now, I know this seems a little bit like what UDEV does with the dev directory, but you'll see it is a little bit different. So again, the system, or Sys directory, the sysfs, is where HAL, the hardware abstraction layer, keeps all the information on the stuff that's connected to the system. So that's where it keeps its database of everything connected. And let's look at that right now. So here we are. This is my Ubuntu system. We're going to start a terminal, and we're going to go to the Sys directory. Again, this is the Sys file system. Now, if you look, this is pretty simple looking. It's divided into a bunch of different categories. Block devices, for example. We'll look at block devices. These are different devices that are connected to the system. Let's look at the bus directory. Now in here you're going to see a bunch of different things. You're going to see USB, USB serial, PCI, PCI Express, and this is where you're going to start to understand the difference between the Sys directory and the UDEV, dev directory that we're going to talk about in a minute. Because remember I said that HAL abstracts things out? Again, the computer, the programs running on the computer don't really care whether it's a PCI card or a USB this or that. They just want to know what kind of device it is. So while here we look in USB and there's devices and drivers, LS, USB, devices, here's the different things that are connected, USB 1, USB 2. Let's look in the PCI folder. These are the same kind of things and the different PCI devices that are plugged in. Now see, this is where it just keeps its database of things that are connected. But this isn't very user-friendly. This isn't something that's easy for us to see, and that's why HAL uses UDEV to turn those things into devices as they're inserted and removed. So the Sys directory is HAL, or the hardware abstraction layer. Boy, that's a tongue twister. The hardware abstraction layer database is kept inside the Sys directory. The next thing we're going to look at is the Proc Directory. So let's look at that right now. So the proc file system is where the kernel keeps all of its running commands. It's important to know that it's not a real file system in that it's not written to a hard disk. The proc file system is created in RAM when the computer boots. So again, it's created every time the computer boots. Now another thing about it, the proc file system is where all sorts of different configurations are stored. Now I'm going to put an asterisk here. You can read and write information about the running kernel in the proc file system, but there's some caveats there. So just so you know, the proc file system, you can read things from it, but it's only going to be temporary. Again, since it's created every time the computer boots, if you make changes to the proc system, when you reboot, those changes are going to be gone. And one last thing to note, in all the nuggets that we do, we're pretty much going to assume that you're root, because that's what the LPIC exams assume, is that you're a root user. But specifically with dealing with the proc file system, you must be root. You must be the root user if you're going to manipulate the proc file system, especially if you're going to try to write to it. So let's look at the proc file system and see some of the things that are in there for us to discover. So here I am back in my terminal window, and you notice I'm root. I'm the root user. Let's look into, let's click in here. Let's look in the Proc Directory. Again, this is just a virtual file system. Now, the first thing you're going to notice is all these numbers. Now, what's important about these numbers is what the proc file system, again, it's all of the things currently running in memory, right? Well, all of these are process IDs. For example, one of these numbers is correlated to this GNOME terminal that I have open. The number 1 is the init process, the very first thing that boots on the Linux computer when it starts up. But that's just the process IDs. There's all these other things. Let's look at a couple of them. We'll do the cat command so that we can see what it is. CPU info. This is in the Proc Directory. It's called CPU info, and it basically tells us all the things about the CPU in the computer. You'll see that it's an Intel i7 CPU, 2.67 gigahertz. It has the cache size, the megahertz. It has all this information about the CPU. Again, it created this as it booted up. That's how it got the information. There are some other things like mounts. This shows all of the currently mounted file systems on this computer. Again, it even shows proc. Proc is one of those file systems that's mounted. It's at /proc, and that's where we are right now. So it shows all the mounted file systems on the system right now. Now you'll notice, maybe you didn't notice, but RW, that stands for read and write, because some of these things you can change settings as well. Now let's go, for example, into the Sys folder, and we'll go into FS, file system folder, and in here's a whole bunch of stuff. Now, I'm going to look at this file max. Okay, 50,000. Now what that means is a user can have 50,000 files open at one time, which sounds like a lot. However, if that user is running like a database, like an Oracle database, well, 50,000 files fills up pretty quick. So what you can do is you can change this on the fly to some really big number like 1,000,000, echo that into file max. And now if we look, file max is up at 1,000,000. Now what does that mean? Well, it means that we instantly change the number of maximum files to be open. It's changed. So right now a user could have that many files open. There is a problem. Remember that asterisk I put on the slide on the whiteboard? Well, the problem is that if we reboot the computer, since this is generated on the fly, it's not going to show that for us. Same thing with anything else that we do. For example, if we go back and we do something, oh gosh, I'm trying to think. If we go into the net folder. All right, in here we have net, IP version 4. Okay, all the stuff in here. Now, one of the things that you can do is, I don't know if you're familiar with NAT systems or IP forwarding, but let's see, IP forward 0. So right now, we are not doing network address translation. Now, if we wanted our computer to do that, we can, not cat, echo 1 into IP forward. And now, all of a sudden, in real time, our computer is going to forward traffic. How cool is that? It's pretty cool, right? Well, the problem is when we reboot, it's not going to do that anymore. The place that that information is stored is in a file called sysctrl.conf. Now, inside here, you'll see all of these different things that get added to the kernel on boot. This is what it uses to create that file that we talked about. And the reason I just showed you that IP version 4 forward, see, we changed it in real time, but if we wanted that to happen every single time we booted up, all we would do is uncomment this. Oops. We tried to anyway. Oh. Yeah. Get rid of that comment. And now, next time we reboot, that's going to be populated with IP forwarding turned on all the time. So that etc syscontrol.conf file is where all of those settings are stored, and that's where you need to change them if you want them to be persistent. So there's all kinds of information to learn about in the proc file system. It's worth looking around and investigating. There are some things you can actually set, but you need to remember that they're only going to be temporary. So let's look one more time at the dev directory. Now, we didn't actually go and look at the dev directory before, but we talked about it a lot, so I'm just going to give you a quick view. Now remember, this is created by UDev, and what it does, it creates, remember we talked about the SDA, SDB stuff? Well, this SDA right here, this is my hard drive. This is going to be a serial ATA hard drive. And SDA1 is a partition, SDA2 is a partition, SDA5 is a partition, and what it does, it creates those on the fly as things are put into the system. Here's what I wanted to show you. The other thing, remember we talked about that camera? Like, oh, I know what that is. It's a camera. Well, the same thing with CD-ROM. Now, the CD-ROM, it's hard to say. If it's a serial ATA CD-ROM, it would be down here in SDA. If it's an IDE CD-ROM, it would be up here. Let's see, where is H? No, it's not HDA. It's hard to say what it is. But that's okay, because UDev knows when the CD-ROM is put in, it's supposed to be linked to CD-ROM. So whatever this is, we can actually look if you want. Let's look. ls minus L. We're going to go up to CD-ROM. Oh, it's SR0. That's the actual place that UDev placed the CD-ROM. But it linked it to CD-ROM using those UDev rules. So then now we can just know that dev CD-ROM is a CD-ROM. And this is the folder. This is what it looks like inside the dev folder that UDev creates and manages. So those are the places to find the information, and next we're going to talk about how to modify that information. We already looked a little bit at the proc file system, but next we're going to look at how to change some other things that are running in the kernel. So let's look at that right now. You know what? I'm a horrible person. I lied to you. Before we talk about configuring, I have to show you a couple more ways you can look at information. But because I feel so bad, I'm going to draw you a cat, because, you know, cats are just so friendly. So nose, eyes, whiskers, whiskers. It's a happy cat because it's really happy to learn about UDev rules. And I'm not going to try a body because this has already gone too far. So anyway, let's learn about lsmod. Now, lsmod, lspci, and lsusb, if you're familiar with Linux, you know that ls is a listing command, right? Well, that's what it does. lsmod shows kernel modules. lspci, can you guess what that shows? PCI devices. And lsusb gives you the weather. No, it shows you all of the USB devices that are connected. So let's look at what those look like, and then I promise we'll move on to how to configure more stuff. So these three things we're going to show, it'll determine exactly the types of hardware that's plugged in, and then we can see what we can do with that. Meow, and let's go look at the command line. Okay, this will just be a really quick section. Basically, we just type the command, I'm going to get up in there. ls mod will show you the kernel modules that are currently active in the system. All these on the left, these are all the kernel modules that are currently running in the current computer. Now you can tell by some of these that I probably am running a virtual computer, running VMware. VMXNet is a prime example. It'll teach you that, well, yes, this is a virtual machine that it's currently running in. But these are all of the different kernel modules that are running. Now, the same kind of thing with LSPCI, but the information is a little bit different. Basically, oh, yep, see there, it gave me away. LSPCI shows all of the current PCI devices that are plugged into the computer. So you'll see, let's look at something that's not VMware, Intel Corporation here, the AGP bridge. It recognizes that it's an Intel AGP video type device, right, the PCI bridge. ISA bridge for using ISA devices, IDE interface, all these different things. These are PCI devices. Even though it's a virtual one, it sees this PCI device as a SCSI controller. It actually thinks it's an LSI logic, even though it's really just VMware. But it shows you detailed information on all the different PCI devices that are plugged into the computer. For example, the USB controller is actually a PCI device, right? And speaking of which, what a great segue into LSUSB, which is going to demonstrate the different USB devices that are plugged in. Now, right now, it turns out I don't have any USB devices plugged into my virtual machine, which is fine because it just would show a list of different things. But bus 1 and bus 2, these are both just root hubs. These are the USB devices themselves, but I don't have any other things plugged in. Let me plug something in real quick. So there, LSUSB now shows us that I plugged in the SanDisk ImageMate 6-in-1 card reader. And it just shows us that because, again, I plugged it in, I need to go over here. LSUSB is what I just typed, and there it shows it. So, again, the three commands, LSPCI shows PSI devices, LSUSB shows USB devices, and LSMod shows current kernel modules that are installed. Now, let's talk about adding and removing some of those modules next. So we learned about a whole bunch of different commands, all right? And the different commands, here, I'm going to write them out for you. Now, I know what you're thinking. Whoa, Sean, what's with the extra commands? Well, along with these, that's not real clear, it's not LSMod. With LSMod, LSPCI, LSUSB, there's also things like LSPCMCIA, LSHAL for the hardware abstraction layer, and LSHW for hardware. All of those will show you different things about the current things in your system. Showing all of them in real time is going to just take more of your time, but just go ahead and play with those, and they all just show different aspects of the running system. So now, we know what's running, but what if we want to add or remove kernel modules for different drivers? Now, here's the deal. Linux is really good about detecting proper hardware, but sometimes you still need to add and remove kernel modules or drivers for devices. One really good example that I have the fortune of being able to demonstrate is the idea of the virtual network driver inside a VM. And this is something that I'll show you how to do, but see, the thing is, when you're running a VM, you can get a specialized network card that works better, a driver for it, but the kernel doesn't detect it automatically, so you need to insert that. So let's look at how you would actually insert and remove kernel modules right now. Alright, here we are at the terminal window. We're going to do an ls mod for showing the running modules right now. And remember I talked about that VMXNet being the driver specific for virtual machines. Well, at first when I installed it, it actually recognized it, I think it was as a PCNet driver as opposed to VMXNet. And what you have to do is rm mod. Now, RM should look familiar if you're familiar with the Linux command line. We're removing the module rm mod VMXNet. Alright, oh, now if you look, look at that nice pop-up. Whoa, wired connection is gone. You have no connection. Oh my goodness. In fact, as far as the kernel knows, we don't have any Ethernet card at all. So, how you would historically insert the module is insmod VMXNet, right? Oh, that's the problem. A lot of times, like if you're trying to install a package and there are other dependencies, you can't do things like just insmod. And that's where this awesome tool came around. And this is really the only one you're ever going to use. I doubt you'll ever use insmod for insert the module. Mod probe, what it does, it probes for any other dependencies that will be required. So vmxnet. Okay. Well, this is just warnings. These aren't errors. All configs, blah, 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 because of VMware tools. And you'll see it installed it, and now I have that connection established up there, just inserting the module. Now, what I had to do before was I had to rmmod. It was like PCnet32. Now, it's going to say there is no such module. But I had to remove that, and then I had to mod probe that vmxnet in. Okay? And, yeah, see, it's already inserted. But mod probe is how you insert modules into the running kernel, and rmmod is how you remove them. So now what about if you want them to do it automatically? Well, here I'm in Ubuntu. There's a couple ways. The old-fashioned way would be to edit this etc modules. So the etc modules file. And see here, you can add things to a line. Everything that, or every module on its own line, it'll mod probe those things as the system boots up. But if you go into, then you'll see all of these things. Now, what these are different things that, let's see, okay, what this does, it gives it different commands, and this is a little bit beyond the scope of just how to insert and remove modules, but this is the method that you use to add these things to the running kernel on boot up. So either the etc modules or in the etc modprobe.d folder, all these different files that you can use. And basically that will allow you to add things to the running kernel just like that etc syscontrol.conf file did for the things in the Proc Directory. To add things into the module, the kernel, when it boots up, the drivers and stuff, this is where you would put them. And that is close to it. There are two more things that I want to show you really quick back at the whiteboard. There's always the exception to the rule, right? Well, I talked about the dev file system, making nice little convenient symlinks to different files like USB drives or your camera or your scanner, things like that. Well, what happens if you have several hard drives that you want to mount in a specific place? For example, you want one to be your home directory. You want one to be your root directory. You want one to be the var directory. You know, you have all these different things and you want a specific hard drive on there. Well, you can't just say like dev hard drive and dev other hard drive and dev other hard drive. So what you can do is mount these specific folders based on the UUID. Now you can also mount USB drives with this, but the hard drives are a really good example of why you would use UUID. Basically what you do when you mount the thing, instead of specifying a specific device like instead of dev SDA partition 1, you would specify, well, let's just go look. That's even simpler if we just go look. Back here at the command line, let's look at that mounts thing in the proc folder. Proc cat mounts. Okay, so here we have this is a perfect example. Now what we have done, instead of mounting, this is the root directory, right? I just have one partition here. Instead of mounting / on like dev SDA1, what we're going to do is mount it on dev disk by UUID, and every single device is going to have its own UUID. So what that means is, if you pop in another hard drive, it's not going to take the place of this mount. It's not going to try to mount a different hard drive on there. You can specify based on this ID that it mounts right there. So that's basically, instead of depending on udev to figure out what hard drive it is, you say this exact hard drive named Bob, because apparently in computer this is how you spell Bob, just bear with me. Bob is always going to be mounted on / on the root directory. It's always going to be there. Same thing, now you don't have to do that. For example, what else do we have here? I guess that's the only drive that I have mounted. Yeah, so that's the only one I can show you. This is basically a this is the fuse mount that GNOME uses for having all the things on the desktop, and it just says basically where the directory is and what it is that's being mounted, but it doesn't give you an actual device because it's more of a virtual file system. So basically, if you want to mount a device based on UOUID instead of any entry in the dev directory that is auto-created, this is going to work no matter what. That hard drive is all that's going to be mounted. Pop in another hard drive, it's not going to mount there unless you change the UUID. And really, that's about all there is left to understanding how to manage and configure the hardware. There's a couple things you should know, like what hot plug versus cold plug is, and basically that means hot plug is you plug it in when the computer is running, like a USB disk, and cold plug means you turn the computer off so it gets cold, like if you're going to put in a new video card, well, you can't hot plug that. Although I did know somebody that tried to hot plug an Ethernet card. That doesn't usually work really good either. So hot plug and cold plug, and I think that's about it. So let's go back through a quick recap, and I'll send you on your way to the next lesson. So a quick recap of 101.1, the hardware settings. How to determine settings. Now we learned about HAL and the hardware abstraction layer, and it's important to know that HAL runs actually as a daemon, which is like a server process, so you may actually see it referred to as HAL-D for daemon. D-bus is the method that they use to communicate. Remember my example of the actual bus that drives information back and forth. And UDEV is the application or the program, the daemon that's running in the background that determines what system file or what devices are mounted at in the dev directory. So this is basically in charge of the dev directory. Then we learned about different directories. We learned about the Sys Directory. Now the Sys Directory, you remember, is basically just HAL's database of all the stuff connected to the hard drive. It talks about whether it's PCI, mini PCI, how it's connected, where it's connected, why it's connected, its serial numbers, all that kind of stuff. It has a whole database of stuff. The Proc Directory is the directory that's dynamically created as soon as your computer boots up. There aren't any actual files, they're all just stored in RAM. They can be changed, but they won't keep that setting on reboot. Remember, that's important to know that those are volatile and they will disappear. And then the dev directory. Again, UDEV controls those things, and that's where your devices show up. With UDEV rules, you can actually make them friendly, like you plug in your camera instead of just, dev SDA1, it's dev camera, which is a really convenient way to do that. And that is what the dev directory is. Now, then we learned about all these ls commands. We actually learned about a couple extras, too. lsmod shows kernel modules, lsusb shows USB devices, lspci shows the PCI devices, and then we have lshal and lshw and lspcmcia. All those different programs will show you what's in the current computer, what's plugged into it. And then we finally, after all that learning, learned how to configure some stuff. We learned about how to set device UUID, or how to mount things based on the UUID. Remember, that's the UUID, and that is how you can mount a hard drive or like a flash drive based on its exact unique identifier. So it's not just like, it's not just like dev SDA, it's going to be dev by UUID and the whole long string of numbers that specifically identifies every single block device. So you're never going to have the same thing twice. Everyone is unique. We learned about what kernel modules are. Remember our little example about the network module, the VMXnet that I removed and re-added. That's how you manage kernel modules. That lsmod showed you what they were, but we use the two tools that we use for that are rmmod to remove them, and modprobe to put them back in. We can also use insmod, but remember that's kind of outdated because it doesn't look for dependencies. So rmmod and modprobe for managing kernel modules, and then adding and removing devices. Boy, we just talked about that in length, didn't we? We talked about what happens in the dev directory, what UDEV does, how it communicates with GNOME or KDE via dbus, and we learned all about adding, removing, configuring, identifying, about devices. We've learned more information in this lesson than we probably ever knew existed in virtual file systems and stuff. So, I think that just about covers it. I hope that this has been informative for you, and I'd like to thank you for viewing.